Hello dear viewers, welcome to TV Math Hub. This is your study pattern for competitive examinations. In our today's session, I will be taking you through item number 3 for Senior 5 end of term 3 mathematics exam. We have so far discussed two items, item 1 and item 2. And in case you haven't watched these items, please find the link in the description so you can also follow along with others. So our item number 3 says Miss Daru owns a small artisan shop in Arua City that specializes in handcrafted bowls. Her latest design is formed by rotating the region bounded by the line y equaling to 5 and the curve y equaling to x squared plus 1 about the line y equaling to 5, creating a vase-like bowl. To promote it, she is creating a compact roadside poster that is advertising sign with exactly 80 centimeters squared of space for the key ad text, including the bowl's water capacity. The poster includes margins of 2.5 centimeters on the left and right sides and 2 centimeters on the top and bottom, as shown in the figure below. So let us look at the figure. So here is the figure of the poster plus that is including the advertising space. So this is the poster that is given with the margins on the left and right, 2.5, 2 centimeters on top and bottom. Next, we are again told that Arua City Council regulations require the poster's total length, including margins, to be between 10 centimeters and 20 centimeters for pedestrian visibility and portability. Mrs. Daru wants to minimize the total area of the poster to save on printing costs, while ensuring the ad text fits perfectly in the 80 centimeter squared space. Once designed, she plans to calculate and include the exact water capacity or volume of the bowl. Task: we are told to determine the dimensions of the poster in order to minimize the total area, and 2, to help Mrs. Daru find the water capacity or volume needed to fill the bowl. So that is the information that we are given. And basically, we shall first look at part 1, where we need to determine the dimensions of the poster in order to minimize the total area. So looking at the poster that is given, first of all, we don't know the dimensions of the advertising space, but what we know is that this space here should be taking 80 centimeters square, meaning that the ad text plus the bowl should fit within this advertising space. But for her, she wants to ensure that this space is equaling to 80 centimeters squared. That is the area of the given space, meaning that since we don't know the dimensions of this advertising space, then we need to first of all let the dimensions of the advertising space to be any given unknowns. So that is basically what we shall start with. So we shall look at the given advertising poster. So here we have got what we call 2.5 centimeters. This is also 2.5 centimeters. From here, this is 2 centimeters. From this given point to that, from this given point to that, that is 2 centimeters. So basically, we know that this space here should be having the area of 80 centimeters squared. So what we shall do first, looking at the responses, we shall let x and y, let us let x and y be the length. Let x and y be the length and width of the advertising space. So if that one happens, it means from this given point up to here will be x, from this given point up to here will be y. If this becomes y, then what would be this dimension from here up to this given point? Still from here up to this given point can also be obtained in terms of y, because from here to here is 2.5, this is y, this is 2.5 as well, this is 2. Okay, from here to here is 2, from here to here is 2, from here up to here is y. So this is y plus 4. Also, from this given point to this is 2.5, this is x, this is 2.5, meaning from here up to this given point will be x plus 5. So that implies, this implies that the length, this implies that if x and y are the length and width of the advertising space, then it means the length of the billboard, the length of the poster. The length of the poster will be actually x plus 5. And the width of the poster will also be this one here will be y plus 4. So all these are in centimeters. So if that is the case, let us look at what will be the area of the poster. So what will be the area of the poster? So the area of the poster, of course, area is length times width. So let us first of all get back and look at the information given. We are told that Miss Daru wants to minimize the total area of the poster. So she wants to minimize the total area of the poster. That is basically the information that we are told. So area is same as length times width. Length is x plus 5. Width is y plus 4. Of course, centimeters squared. So this will be same as xy plus 4x plus 5y, then plus 20. So this will be the area of the poster. But we know that the area of the advertising space, the area of the advertising space must be 80 centimeters squared. That is the information we are told. We are told that she wants to minimize the area to save printing costs while ensuring the ad text fits perfectly in 80 centimeters squared space, meaning that this advertising space should remain 80 centimeters squared. So for that case, we can as well say, but when you look at the advertising space, but the area of advertising space is actually same as x times y, but this must be 80 centimeters squared, meaning that xy is 80 centimeters squared. So from here, I can have y as 80 divided by x. So if that is the case, then it implies that the area of the poster, so this is the area of the poster A, will be same as xy, we have seen is 80, plus 4x, plus 5 times y, that is 5 times 80 divided by x, then plus 20. So this will give us, this is 100, this will give us 100, plus 4x, 5 times 80, that will give us 400, and this is divided by x. So this is the area of the poster in terms of x. But again, we are again told that Arua City Council regulations require the poster's total length to be between 10 centimeters and 20 centimeters. To be between 10 centimeters and 20 centimeters. So it means the area should be the total length should be lying within this given region, that is between 10 and 20. So for that case, then we need to basically also talk about that given constraint. So we are therefore told, but the length of the poster is x plus 5. So it means that x plus 5 should be between 10 should be between 10 and 20, should be between 10 and 20. So for that case, it means this would be 5 should be less than x, which should be less than 15, meaning that the value of x should be between 5 and 15. So let us go on and look at how best we can minimize the area of this given poster. So next we shall write and say our interest is to therefore we must determine, this is our interest, therefore we must determine the minimum area, the minimum area in the interval, minimum area, which would be in the interval of 5 less x less 15. Okay, so let us look at that. So how best can we minimize the area? So we shall first of all, since we are to talk about minimizing the area, and we have our area as this, we have our area as 100 plus 4x plus that. We shall first of all get the first derivative. So let us get the first derivative. That is getting dA dx. So what will be dA dx? Remember, we have 10, that is 100, plus we have 100 plus 4x, then plus 400 divided by x. So we are differentiating this. Remember, this can be as well written as 100 plus 4x plus 400 x to power negative 4. So differentiate this. So differentiate with respect to x, 100, 4x, 400 x to power negative 1. So when you differentiate this, this will be 0. Differentiate the constant, get 0. Differentiate 4x, get 4. Differentiate x to power negative 1. So you will have to drop the negative. So it will be 400 times the negative 1. Then reduce the power by 1, it becomes negative 2. So this is 4 minus 400, then divided by, so we are dividing by x squared. So this is our dA dx. But we understand that for minimum or maximum, then the dA dx should be equal to 0. So for that case, let us equate this one to 0. 4 minus 400 divided by x squared is equal to 0. And we go on and get the values of x. So this will be same as 4, which is equal to 400 divided by x squared. Let us bring this one that side. 4x squared is equal to 400, which means x squared is equal to 100. So for that case, x will be plus or minus 10 when you take the square root of 100. So we have got two values of x as x equaling to 10 and x equaling to, you have either x is equal to 10 or your x is equal to negative 10. So from these two values of x, we need to determine which one minimizes the area. And for that case, we shall look at the nature by basically looking at or using what we call the second derivative test. So we want to look at the nature of these values of x, whether they are minimizing or maximizing the area. Since we said for minimum or maximum, that first derivative should be equal to 0, meaning any of these can be giving us minimum or maximum. So let us look at the nature of these points by getting the second derivative. So let us look at the 2a, the x squared is same as differentiating with respect to x, this one here. So this is same as 4 minus 400 x to power negative 2 when you bring it up. So this will be, drop the negative 2, so this is negative 400 times the negative 2 x to power negative 3. So this would be 800 divided by x to the power of 3. So this would be our d2a dx squared. So if that is the case, we are interested in substituting x equaling to 10 and x equaling to negative 10. So let us substitute x equaling to 10 and we see what would be the nature of d2a dx squared. So looking at for x equaling to 10, it means d2a dx squared will be actually same as 800 divided by 10 to power 3. So when you look at this, this value will be greater than 0. This value will be greater than 0, which means x equaling to 10 minimizes the area. Okay, we can go on and look at for x equaling to negative 10. So what will be the 2a dx squared? So the 2a dx squared will be same as 800 divided by negative 10 to power 3. So when you look at this, this will be 800 divided by negative, because negative to power 3 remains negative. So this will be negative of 1000. So this value will be less than 0. And for that case, it implies that x equaling to negative 10 actually maximizes the area. So if that is the case, since our interest is to get the value of x, which gives a minimum area, then we shall conclude that therefore x equaling to 10 gives a minimum area in the interval, Remember, our interval was 5 less x less than 15. Our interval was 5 less than x less than 15, and we can easily see that x equaling to 10 is truly within this given range. So if that is the case, let us now see how best we can now answer this question that was given. So we need to determine the dimensions of the poster in order to minimize the total area. So what would be the dimensions of the poster? Since we have got the value of x, which minimizes the area, so we can go on and get the values of y. So what will be? So the dimensions, let us look at the dimensions of the poster. So the dimensions of the poster, we are to look at the length. Length was so the length of the poster was x plus 5 and width was y plus 4. So let us look at the length was x plus 5, so which means it will give us 10 plus 5, which will be 15 centimeters. So what would be the width? The width was y plus 4. Okay, so we haven't got y. We need to first of all get the value of y. So we need to get the value of y. So we know y is 80 divided by x. Let us get the value of y. So we are saying that y is same as 80 divided by x, which means it will be 80 divided by 10, which will be 8 centimeters. So if that is the case, then it implies the width of the poster will be 8 plus 4, and this will give us 12 centimeters. So this will be the dimensions of the poster. So we can also go ahead and get the volume. So what, and get the area. Can go ahead and get the area of the poster. So what would be the area of the poster? So the area of the poster, that is the minimum area. So the minimum area of the poster, would be length times width, but of course our length is 15. So this would be 15 centimeters times 12 centimeters. So basically this will give us the minimum area of 180 centimeters squared. So in conclusion, we can therefore say this implies that the poster will be of length 15 centimeters and the width 12 centimeters with a minimum area of 180 centimeters squared. So that is basically what was required in part 1. So we have got the dimensions of the poster, which will minimize the total area while maintaining the area of the advertising space as 80 centimeters squared. So that is basically what was required, and we can now look at part 2, where we need to find the water capacity or the volume needed to fill the bowl. So looking at part 2 says, help Mrs. Daru find the water capacity or the volume needed to fill the bowl. So let us get back to the given information. We are told that Miss Daru owns a small artisan shop in Arua City that specializes in handcrafted bowls. Her latest design is formed by rotating the region bounded by the line y equaling to 5 and the curve. So which means to obtain this bowl here, or the volume of this barrel, we shall be rotating region bounded by the line y equaling to 5 and this curve. Then we rotate it about the line y equaling to 5. And from there we shall be able to obtain the volume of this region, which is obtained by rotating the region bounded by the line, this one, and this curve. So that is basically how we shall answer part 2. So let us look at the required response for part 2. So in part 2, our major interest is to sketch the curve y equaling to x squared plus 1 and the line y equaling to 5. So we sketch the two, then we get the region which is bounded by this curve and this line. So let us look at sketching. Let us look at sketching the curve. Sketching the curve y equaling to x squared plus 1. To sketch this curve here, we need a few things. One, we need to look at the intercepts. So for intercepts, we have got for y-intercept, and for y-intercept, we have x as 0. So for y-intercept, x is 0. If x is 0, then what will be y? Y will be same as 0 squared plus 1, which is equal to 1. So our point here will be 0, 1 as the y-intercept. So we also talk about x-intercept, and for x-intercept, y is 0. So if y is 0, this will imply that 0 is same as x squared plus 1, which means that x squared is equal to negative 1. And for that case, this implies that x is same as the square root of negative 1, plus or minus. But we know square root of negative 1 is a complex. So if that is so, then it means this will imply that the curve does not cut x-axis. The curve does not cut x-axis. So that is what basically it means. Okay, so having looked at that, let us go on and look at what we call the turning points. So in order to sketch this curve here, we shall look at the intercepts, we shall look at the turning points, nature of the turning points, then we shall be in position to sketch this curve. So let us talk about the turning points. Turning points. And for turning at a turning point, then you understand that the y dx is 0. So let us first of all get the y dx. So we shall have from y equaling to x squared, plus 1, from y equaling to that, then it will imply that our dy dx will be same as 2x. When you differentiate this, you will get 0. So we remain with dy dx equaling to 2x. Then after that, for a turning point, dy dx is equal to 0. For turning point, dy dx is equal to 0. So this will imply that 2x is equal to 0, and which also implies that x is equal to 0. So we shall be in position to get the value of x as 0. So we need to get the corresponding value of y. So what will be the corresponding value of y? So from y, which is equal to x squared plus 1, for x equaling to 0, we shall have y equaling to 0 squared plus 1, giving us y as 1. So therefore, 0, 1 is a turning point. So we have got 0, 1 as a turning point, but we need to first of all look at the nature of that turning point. So what is the nature of the turning point? Is it a maximum, a minimum, or not? So nature of the turning point. So we obtain the nature of the turning point by getting the 2y dx squared. That is differentiating for the second time dy dx. So when you differentiate for the second time dy dx, this is same as differentiating dy dx for the second time. So we have got our dy dx as 2x. So you are differentiating 2x, and this will give us 2. But this 2 is greater than 0. So it means that the 2y dx squared is actually greater than 0. And if it is greater than 0, then it means your turning point is actually a minimum. This is a minimum point. Okay, so we have got the turning points. We have got the intercepts. So we shall also look at the nature of the curve. Where does it tend to? So let us look at if x is tending to positive infinity, where is y tending to? Remember, your y is same as x squared plus 1. So if your x is going to positive infinity, is increasing positively, where will y be tending to? So it is same as substituting. You basically look at the highest power of x. So the highest power of x is 2. So if x is positive, what will happen to y? So you are basically talking about y equaling to x squared plus 1. So if x here is a positive value, a very big positive value, what will happen to y? Since it is squared, if any number squared will always give you a positive. So meaning y will be positive. So y will also be tending to positive infinity. So from there, if x is tending to negative infinity, where will y be tending to? Y will be tending to, remember, your y is x squared plus 1. So if this is a negative, if x is a negative value, so x squared will still give us a positive value. So this will still remain positive infinity. Okay, so that will help us in the sketch. Okay, so the next thing to do, since we are to draw the curve and the line, we must get the point of intersection. So the next thing that we should talk about is looking at the point of intersection between the curve and the line that we are considering. So let us look at the point of intersection. So what will be at the point of intersection between the curve and the line? The point of intersection, remember, we are having y equaling to 5 and y equaling to x squared plus 1. So the point of intersection is obtained where this one here is equal to that. So for that case, the point of intersection will be obtained at the point where x squared plus 1 is equal to 5, where this will be equal to 5. That will be the point of intersection. So this means that x squared is equal to 4 and x is same as plus or minus 2. So this will give us x as positive 2 or x as negative 2. So if x is equal to 2, what will be y? It means y will be same as 2 squared plus 1, which is 5. So you have 2 and 5 as your point. Next, for x equaling to negative 2, y will be equal to negative 2 squared plus 1, and this is also 5. So from that, it means also negative 2 and 5 will be your point of intersection. So therefore, points of intersections are points of intersection will be 2, 5, then negative 2 and 5. And that will be the required answer for the point of intersection. So having got all that, our major interest now is to draw the curve. So let us try to draw the curve and this line. So if we are having our sketch as that, so basically shall have that. So we need to draw the curve. We have got the points of intersection, we have got the turning points, we have the intercept. So looking at that, we have got our intercept 0, 1, and it does not cut the x-axis. Okay, we have got our turning point, which is 0, 1, which is a minimum point, and x tends to positive, y tends to positive, x tending to negative, y tends to positive. Okay, so let us first put the point of intersection. So the points of intersection, we have negative 2 and 5. So we can have 5 here. So this is our 5. So this will give us this point. This is negative 2 and 5. And another point is 2 and 5. 2 and 5. So 2 and 5 will be at this given point. So from there, so now let us put the intercept. Intercept is 0, 1, but it does also not cut the x-axis. So let us first put 0, 1 as our intercept. So if this is 0, 1, let us have this 1 as this point. So this is our point which is 0, 1. This is our point which is 0, 1. So this is our line. This is our line y equaling to 5. So that is basically what we are having. Then the points of intersection, we have put the turning point. The turning point is 0, 1 and it is minimum. And that is the information so far we are having. Then we are told that when x is tending to negative infinity, we have that when x is tending to negative infinity, y is to positive, x tending to positive, y is to positive. So when we try to put that, it means as x is tending to positive, we shall have a y moving to the positive direction. We shall have y moving to the positive direction. When x is tending to negative, this side, y is also still tending to the positive direction. So we shall now sketch. Our curve should pass through this point here. It must also go through this point here. This is a minimum point, so it should turn from this given point, and it should also move through this given point, and it moves in that direction. So this is our curve y equaling to x squared plus 1. So we want to rotate this region here along this line here. So when you do that, then you are trying to rotate it along this same line. So trying to rotate, then we shall get a figure in that nature. So basically we are interested in knowing the radius. We are interested in knowing the radius of this area here. Since we are to use the disk method, then we must know the radius. So from this given point up to this given point is which radius. So from here up to here will be taken as the value of y. So this is 5, this is the curve. So we shall get the difference between this line and the one below, which is this. So we get 5, this will be 5 minus y. So where y is x squared plus 1. So this will be taken as our radius. And the change is along the x-axis, because we can see from here up to this given point, this is our delta x. So this is our delta x. So there is a small change along the x-axis. Along the y, we shall have 5 minus y. Okay, so let us now look at the volume. The region that we have actually rotated is this region. This is the region we are rotating. And when you get just a small disk, you realize the change will be along the x-axis, and along the y we shall have 5 minus y. So let us look at the volume. How do we get the volume? A volume will be obtained by using the disk method, and that will be same as having V, or the volume. So the volume is same as pi integral. So the points of intersection will be our limits. That is negative 2 to positive 2. So that will be our points or our limits. So negative 2 to 2 of y squared dx. So from there we shall be interested in obtaining. So we are interested in obtaining the volume. So we are saying volume is same as that. So which is same as having pi from negative 2 to 2 y squared. Okay, actually the radius we are taking is 5 minus y. So this should be 5 minus y, not simply y. So this should be 5 minus y. That is our radius squared, then dx. So this will be same as 5 minus y. Y is x squared plus 1. Then the whole of this one is squared dx. So this will be same as having pi from negative 2 to 2. This will be 5 minus that one will be 4. So this is 4 minus x squared, and the whole of this is squared, then times the dx. So this will give us pi from negative 2 to 2. Expand this will be 4 squared minus 2 times 4 times x squared, and then plus x squared again squared, that will be x to power 4, and then dx. So this will basically be same as from negative 2 to 2 of 16 minus 8x squared plus x to power 4, and then dx. So we shall integrate this. So this is same as pi into, so this will be 16x minus 8 over 3 x to power 3 plus x to power 5 divided by 5, and we are having from negative 2 to positive 2. So let us put our limits. So our limits, we shall begin with when we put the upper limit, that is 2. So this will be 16 times 2 minus 8 over 3 into 2 to power 3 plus 2 to power 5 divided by 5. This we shall subtract when we put negative 2. So 16 times negative 2 minus 8 over 3 into negative 2 to power 3, then plus negative 2 to power 5 divided by 5. So that is basically what we shall have. So this will be same as pi into, this will be same as pi into, let us simplify this. This will be 16 times 2, that is 32. This will give us 32. Minus, this is 8 times that, that is 64 over 3. That is 32 over 5. So from that, we are subtracting negative 32. So it means we are adding. So this is minus, I'm opening this bracket, minus 16 times negative 2 is minus 32. So this is plus 32. Then minus, this will give us a minus. This will be a minus. There is also another minus. So finally, it should also remain a minus. This is 64 over 3. Then this is minus. What we obtain here will also be minus 32 over 5. So it will give us plus 32 over 5. So simplify this. Get 32 plus 32. Get this one plus this. Get this plus that. And you should be able to get a 512 divided by 15. So this will give us volume as 512 divided by 15 pi. So this is cubic centimeters or cubic units. So this will be at the volume. This will be at the volume. This will be at the volume of the bowel. So we are interested in helping Miss Daru find the water capacity needed to fill the bowel. So the capacity or the water capacity needed to fill the bowel. Therefore, the water capacity needed to fill the bowel is 512 divided by 15 pi centimeters cubed, and that will be the required answer. So from there you will have answered this, and that is basically the required response. Please, if you find this video helpful, don't forget to subscribe, to like and share this video to your friends. We meet in our next item.